Alright, last example, or last video, sorry, we're going to do a couple of examples. So, first one, we're sketching y equals x plus 1 cubed plus 8. Okay, again, just thinking about our starting point, which is our x cubed graph. Alright, so the dotted line, that's my starting point. Now that 1, what does it do? Well, it moves it across 1 to the left, the opposite of positive. So it's going to move it across 1. So I might just do it like this. So it's going to move it across by 1. And what does that 8 do? Well, that moves it up now. So here's our reference point, basically. So for our starting point, reference for x cubed, we start there. We move it across 1. Okay, and then we're going to move it up 8. So somewhere up here. And it's still got the same shape. We're not dilating it. So, okay. I'll just redraw that so we can say that this equation here is going to look like this shape here. So something like that. Just want to label it. So here we've got, we moved it across 1 and we moved it up 8. No dilation. So that's all good. So that's the stationary point of inflection, where it changes from concave down to concave up. Right, I could find that x-intercept and the y-intercept. Okay, x-intercept, to find that we just solve it for x. We'll go minus 8 equals x plus 1 cubed. Okay, cube it, so it's going to be minus 2 x plus 1. Take 1 on both sides, so x is minus 3. Okay, so that point there is going to be minus 3, 0. Our y-intercept, okay, finding it when x is 0. 0 plus 1 cubed plus 8, so that's going to be 9. So they're the 3 points that we want to put in. Our x-intercept, our y-intercept, and our stationary point of inflection. Pretty straightforward, okay, mainly because we didn't have a dilation. Next part, okay, we've got y equals 6, take a half, x take 2 cubed. A little bit more complicated. First step, just rearrange it so it looks something like this. So we've got something cubed, well, we've got minus a half here as our a, minus 2 cubed, and just moving the 6 over there. Okay, what's it do? That 2 moves it across to the right once, moves it up 6, and that half makes it more narrow. Okay, so again, just thinking about, I'll do some miniature sketches. Okay, this is what we start with. Minus 2, we move it across. Next part, that 6 moves it up. And then that half makes it more wider, remember? So it'll look like something like that. Okay, so just as a rough sketch, okay, and I want to try and find that stationary point of inflection. I want to find the x-intercept and the y-intercept. Alright, let's have a look. So stationary point of inflection. Let's find the x-intercept first. So x-int, okay, how do we find that? Well, we do that when y is equal to 0. Just rearranging it, so we'll have times by 2 to get rid of the half. Okay, cube root it. And we'll plus 3. Cube root of 12, yeah, that's not easy. Just leave it as that for the moment. So here's our x-intercept. Now y-intercept, we'll have y equals minus a half x, okay, is 0 at the y-intercept, so we'll put 0 cubed plus 6, minus 2 cubed is minus 8, times by minus a half, well that gives us positive 4 plus 6, so our y-intercept is actually 10. So here's our y-intercept at 10. We've got the cube root of 12 plus 3, not very nice. Just need to find this stationary point of inflection. And if you remember from our key features, stationary point of inflection at HK. H is 2 and K is our constant, which is 6. So stationary point of inflection is going to occur at 2, 6. So that's graphing cubic functions.